linear combination of this 2 cross 2 matrices, because of A is 2, B is 1, C is 1. So 5 1 minus 1 9, that is equal to 2 into 1 minus 1 0 3 plus 1 into 1 1 0 2 plus 1 into this in matrix 2 2 minus 1 1. So here we express this matrix into a linear combination of these 3 matrices quite easily. So we solve this question. Next question. Question 4a. Consider the basis S is equal to V1 V2 for R2, where V1 is equal to 1 1 and V2 is equal to 2 3. So let T from R2 to P2 be the linear transformation such that T of V1 is equal to 2 minus 3x plus x square and T of V2 is equal to 1 minus x square. Then find the formula for T of AB. Okay. Now you can see we have a mapping transformation is from R2 to P2, right? P2 is a set of polynomial of 2 degree R2. Now we have basis vectors for R2 for domain, and also we have T of V1 and T of V2, right? Also we have T of V1 and T of V2. So then find the formula of T of AB. Find the formula of T of AB that we want to find. Now you can see V1 and V2 are basis vectors for R2. That means what? For any vector of R2 can be expressed as linear combination of V1 and V2 clearly, right? By the definition of basis, these two vectors are basis vectors. That means what? Basis vectors of R2. That means what? Using the definition of basis, we can say that in any vector of R2 that can be expressed as linear combination of V1 and V2. So we are using that one. Let AB belongs to R2, right? So AB can be expressed as linear combination of V1 and V2. That means AB is equal to K1 into 1 1 plus K2 into 2 3. So AB is equal to K1 plus 2K2, K1 plus 3K2, right? AB is equal to K1 plus 2K2 and K1 plus 3K2. So that's why K1 plus 2K2 is equal to A and K1 plus 3K2 is equal to B, right? K1 plus 2K2 is equal to A and K1 plus 3K2 is equal to B. So that's why K2 is equal to B minus A, right? Why K2 is equal to B minus A? Because of when we add equation 2 minus equation 1, you can see when we take 2 minus 1, so K1 will be cancelled out. Finally you will get 3K2 minus 2K2, that means K2, that is equal to B minus A, right? Quite easily. So you will get K2 is equal to B minus A, and put the value of K2 in one of the equation from these two equations. You will get K1 is equal to, put K2 is equal to B minus A in this first equation. So clearly you will get K1 is equal to A minus 2B minus A minus 2B plus 2A, right? So finally you will get K1 is equal to 3A minus 2B. Okay. Now put the value of K1 and K2 in this first equation, right? Put the value of K1 and K2 in this first equation. So you will get AB is equal to, this is K1, right? This is the value of K1. The first equation of the solution is AB is equal to K1 1 1 plus K2 2 3. Now this is the value of K1, this is the value of K2. So AB is equal to 3A minus 2B into 1 1 plus B minus A into 2 3. So T of AB is equal to 3A minus 2B into t of 1 1. Now applying t on both the side, right? Our transformation is t. Now we are applying t in both the side. You will get t of AB is equal to 3a minus 2b into t of 1 1 plus b minus a into t of 2 3, right? Because of t is a linear transformation. So when we applying t on both the side, this 3a minus 2b and b minus a both are constant. So it can be we can take outside of the bracket. So that's why here we are written 3a minus 2b into t of 1 1 plus b minus a into t of 2 3. Now t of AB is equal to 3a minus 2b. Now t of 1 1, the value of t of 1 1 and t of 2 3, that is already given in the example. You can see the value of t of 1 1 here 2 minus 3x plus x square, and t of v2, that is 1 minus x square. Okay, so that is already given in the example. So that's why we are using here t of 1 1, that is 2 minus 3x plus x square, and t of 2 3, that is 1 minus x square. All others are same, right? All other value are same, t of AB. So finally you will get t of AB is equal to 3a minus 2b into 2 minus 3x plus x square plus b minus a into 1 minus x square. Okay, now from this equations we want to find out the second degree polynomial. How we get? First of all, we want to write the constant term. So what is the constant term of this step? You can see 2 into 3a minus 2b. So you will get 6a minus 4b, then 1 into b minus a, so plus b minus a. So you will get 6a minus a, that is 5a, minus 4b plus b, that is minus 3b, correct? Similarly, the coefficient of x. Now I want to write down the coefficient of x. So that is minus 3 into 3a minus 2b, that is minus 9a plus 6b into x. And here in the second step there is no term of x. So finally you will get minus 9a plus 6b into x, plus now I want to write down the coefficient of x square, that is 3a minus 2b into x square. So 3a minus 2b plus b minus a into minus 1, so that is plus a minus b into x square. So 3a plus a, that is 4a, minus 2b minus b, that is minus 3b into x square. So t of AB is equal to 5a minus 3b plus minus 9a plus 6b into x plus 4a minus 3b into x square. So that's why t of AB is equal to finally you will get this value, right? So here we find the t of AB. The next question, question 4b, verify rank nullity theorem for the linear transformation T from R4 to R3 defined by T of x1, x2, x3, x4, that is equal to 4x1 plus x2 minus 2x3 minus 3x4, 2x1 plus x2 plus x3 minus 4x4, 6x1 minus 9x3 plus 9x4. And this question was asking 5 marks. Here is the solution. T is a linear transformation, so hence standard matrix for T we denote as, from the first coordinate we can write down the first row, right? Because of T is a Euclidean linear transformation, in Euclidean linear transformation we can definitely find the standard matrix for that transformation using this simple method. that this is the first coordinate. How many variables we have? x1, x2, x3, x4. So the first row is coming from the first coordinate and exactly the coefficient of x1, x2, x3, x4. So the coefficient of x1, x2, x3, x4 in the first equation, that is 4, 1, minus 2, minus 3. So 4, 1, minus 2, minus 3. From the second coordinate, the coefficient of x1, x2, x3, x4, that is 2, 1, 1, minus 4. 2, 1, 1, minus 4. And the coefficient of x1, x2, x3, x4 from the third coordinate, that is 6, 0, minus 9, 9. Okay. Now rank of T, that is equal to rank of A. Rank of this transformation T, that is exactly the rank of the standard matrix for the transformation T. Okay. So, and we know that to find the rank of T, rank of a matrix, what we have to do? We are converting this matrix into a row echelon form, and number of non-zero row in that row echelon form, that is exactly the rank of the matrix, and that is exactly the rank of the transformation, right? And to find nullity, here we want to find, here we have to verify the rank nullity theorem. Now first of all I want to explain that what is the rank nullity theorem. Now rank nullity theorem, that is for the transformation T, that is rank of transformation T plus nullity of transformation T, that is equal to number of column, right, in a standard matrix of that transformation T. Okay. So number of column of the standard matrix for the transformation T. So here we have 4 number of column, right, that is clear. And we want to prove that rank of transformation T plus nullity of transformation T, that is equal to 4. That we have to prove. So let's one by one. First of all we find rank of transformation T, and then we find nullity of transformation T. To find nullity of transformation T, now what is the meaning of nullity? Dimension of the null space. That means how many basis vectors in a null space, that is exactly our nullity, right? So first of all we are converting this matrix into a row echelon form, and the number of non-zero row, that is our rank of the transformation. Okay. So let's see, this is our matrix, standard matrix A. To find rank of A, we are converting A into row echelon form. So A is equivalent to 2, 1, 1. We are interchanging first and second row. First and second row we are interchanging. So 2, 1, 1, minus 4. The second row is now 4, 1, minus 2, minus 3. And the third row is 6, 0, minus 9, 9. Now first row is as it is. We are converting, we are multiplying first row with minus 2 and add into the second row, and also we are multiplying first row with minus 3 and add into the third row. Okay. So the first row is as it is, 2, 1, 1, minus 4. The second row is now you can see 4 minus 4, 0, then 1 minus 2 minus 1, then minus 2 minus 2, that is minus 4, that is minus 3, plus 8, that is sorry minus 3 minus 8, that is minus 11. Now next process, we are multiplying second row with minus 3 and add into the third row. So the third row is now 2, 1, 1. The first and second row are as it is, 2, 1, 1, minus 4, 0, minus 1, minus 4, minus 11, and the third row is now 0, 0, 0, 30, right? So you can see minus 3 plus 3, 0, then minus 12, plus 4 into 3, that is also 12. So minus 12 plus 12, that is 0, and then minus 3 plus 33, so that is 30. So the third row is 0 0 0 30, right? First and second row are as it is. So how many non-zero rows we have? We have 3 non-zero rows. So that's why the rank of the matrix, that is equal to 3, right? Now we want to find the nullity of transformation T, and for that we want to find null space. So from the last matrix we have 2x1 plus x2 plus x3 minus 4x4, that is equal to 0. Okay. So 2x1 plus x2 plus x3 minus 4x4, that is equal to 0. Now from the second row, minus x2 minus 4x3 minus 11x4, that is equal to 0, and from the last row we have 30x4 is equal to 0. So finally we get x4 is equal to 0. Put the value of x4 is equal to 0 in this equation, you will get x3 is equal to, let x3 is equal to k, right? Because in the third column we don't have any leading entry. You can see the first column we have leading entry, the second column we have leading entry, and the fourth column we have leading entry, but the third column we don't have any leading entry. So that's why we are taking x3 is equal to k. Now putting the value of x3 is equal to k in this equation, we get x2, right? x2 is equal to minus 4k, and put the value of x2 is equal to minus 4k in this equation, we get x1 is equal to minus 5k by 2. So hence the null space of T, that is equal to k into minus 5 by 2 minus 4 1 and 0. So this is a basis vector minus 5 by 2 minus 4 1 0, and rank of this transformation, that is 3, right? And the basis for the null space is 1. So clearly 3 plus 1, nullity of T is equal to 1. And now rank nullity theorem, that is rank of T plus nullity of T, that is equal to number of column. So 3 plus 1 is equal to 4.